guys, so in this video we are still discussing on the annual worth analysis. So in annual worth analysis, basically you converted all the cash flow in your cash flow diagram into an equivalent annual series. Okay, so what if you encounter a situation involving a permanent investment or it have an infinite lifetime? What kind of project have an infinite lifetime? Let's say, for example, you are involved in the project of building the Great Wall of China. So historically, the Great Wall of China, it takes up to 2,000 years to build the whole structure. So we can say that that is a lifetime investment. We don't know when it will end. Okay, so if you remember from the previous chapter, long time ago, every time you encounter the situation with a permanent investment or an infinite lifetime, we will use the formula of capitalized cost. And this time around, we are going to modify that formula so that we can perform the annual worth analysis. Okay, if you remember, the formula for the capitalized cost is actually the value of present worth, which is equivalent to the annual worth divided with the interest rate. So in this case, if you are performing the annual worth analysis, you wanted to calculate the annual values. Okay, so in order to get the annual values, you can rearrange the capitalized cost equation to become annual series, or the A is equivalent to present worth multiplied with the interest rate. Quite simple. So let's look at an example. So in this example, you have to decide between two different machines. Both of these machines have different initial cost, different operating costs, different salvage value, and different warranty time. So for example, let's say the machine on the left side is machine C. Its initial investment, or the first cost of this machine, is $50,000, and its annual operating cost is $20,000 per year. The salvage value, if you sell it, is $5,000 at its end of life of 5 years. So maybe we can say this machine have 5 years of warranty, and after 5 years you can return it to the manufacturer at a salvage value of $5,000. Okay, the machine on the right side, let's call it machine D. It is more expensive because it have higher first cost of $250,000, and its annual operating cost is interestingly much lower, which is $9,000, and the salvage value is $75,000. Maybe maksudnya kalau rosak at any time, so you can return it to the manufacturer and you can get a salvage value of $75,000. It have a lifetime of warranty. Maknanya dia yakin that this machine would not break down. That's why the company can guarantee you such term. Okay, so in this case, the life of machine D is infinity. So how are we going to solve this? Let's say if the interest rate is set at 10%, which machine should we choose? Machine C or machine D? Okay, now let's look at the cash flow diagram of machine C. We know the warranty life, or the life of this machine, is 5 years, and then we know that the initial cost is $50,000. So that's the cash flow is pointed downwards because you are spending money to buy this machine, and the amount of money is $50,000. And then the annual operating cost is $20,000. So from year 1 to year 5, you need to spend $20,000 for its operating cost. The salvage value of this machine is $5,000. So salvage value is measured at the end of the machine life, which is year 5, at $5,000. So now let's perform the annual worth analysis for this cash flow. So we know in annual worth analysis, you have to convert all the cash flow into an equivalent annual series. So first, convert the red line here, or the initial investment of $50,000, and then you have to multiply it with the AP factor. Remember the negative sign because it is pointed downwards. So the interest rate set is at 10% and the year is at 5. And then let's move on to the green line, which is the annual series of negative $20,000. Do you need to multiply it with any conversion factor? No need lah, because it is already in annual series. So the next one is the salvage value. The salvage value is positive $5,000. Do you need to multiply it with conversion factor? Yes, of course, because it's like a single cash flow, kan? So you have to multiply this with the AF factor. The interest rate is 10% and the N is 5. Things are quite simple. From here, you find the AP and the AF factor from the compound interest table and key in the value in your calculator, and you will get the annual worth of machine C to be negative $32,371. Okay, interesting. Now let's evaluate machine D. So in machine D, oh dear, we do not know when is the end of life of this machine, but we do know that it have an initial cost of $250,000, and we do know that the annual operating cost is $9,000. How about the salvage value? We don't know where we should put the salvage value because the time is simply infinity. Okay, so we can just ignore the salvage value in our cash flow. Now, if we do the annual worth analysis similar to machine C just now, so let's say we want to convert the cash flow at year 0, so negative $250,000 minus, multiply with the AP factor and then minus with the annual series of $9,000. Oh, here, we do not know what is the end value here because the end value is infinity. So remember from my previous slide or from the previous video, we already stated that we can modify the capitalized cost equation to become annual series is equivalent to P multiplied with I. So we are going to use this equation to find our equivalent annual series for the initial investment. So padam, and restart a new equation. So the new equation for the annual worth analysis is the present worth, which is negative $250,000 multiplied with the interest rate of 10%. So in this formula, actually, you have to write it as 0.1 and then minus with the annual series of $9,000. Do you need to multiply with any conversion factor? No need, because it is already in annual series. So the calculation is much simpler here, and you will get the annual worth of machine D to be negative $34,000. Now compare between machine C and machine D, which have the higher numerical value. Machine C lah kan. So that is why from this evaluation we can choose machine C because it have higher numerical value compared to machine D. Let's look at the theoretical idea of life cycle. Everybody have its own life cycle. I have my own life cycle. You have your own life cycle. Our life cycle as a human starts with being born, and then we grow up to become a very cute baby, and then we grow up to become a child with so many tantrums and that cranky teenagers, and then as we grow older we become mature adults, and at the end of the time we become very old and senile, and at the end of our lifetime we die. Okay, so even in product, it have its own lifetime, like this phone. It starts with the design process, and then it starts with the assembly of the components, and then every distribution to the user, or even operation and maintenance activity, and then at its end of life, and I cannot use it anymore, I dispose it, phase out or disposal. Okay, the same goes with project. The life cycle of a project is very similar to the life cycle of a product. It begins with identifying what are the requirements in the project and the design of the project, and then acquisition and installation of raw materials, and after that the there are more activities on operation and on maintenance, and towards the end of its life cycle, the quality begin to degrade, and then that particular project will be phased out and it will be disposed. So the cost distribution differ by phase. Okay, the cost during the early stage of the life cycle, during the identifying the technical requirements, coming up with the design, is relatively low, and then the cost keep on increasing during the acquisition of the raw material and installation of the facilities, and then the biggest chunk of the cost would usually fall under the operating and maintenance, because it's a long process. Okay, the operating and maintenance is a long process, and finally, even during phase out and disposal also, there may be some minimal cost incurred. Kenapa bila nak buang projek pun ada cost? Of course, when you want to dispose something, you have to find a waste treatment center, or you have to deal with some third party to arrange or to audit your materials or your raw materials that you have. Okay, so in the life cycle cost analysis, it includes the costs of the entire lifespan of a project, from the conceptual idea to the disposal. And then the best life cycle cost is when it is largest at the maintenance and operation, the middle part of it. So we will not go into detail in the life cycle cost analysis. This is just a brief overview and idea on how the life cycle cost analysis looks like. Probably you would have to remember the punya cost distribution too. Okay, so that is all for now. That is the end of the annual worth analysis. Till then, please stay tuned. We have another 2 chapters left. So see you later, alligator.